Let's do exercise 3 on the handout where we're going to work with this idea of vertical stretching or compressing. On the handout, exercise 3 is at the very bottom of a page and it says the graph of f is given below. There's no below because the graph of f actually appears at the top of the next page. So sorry about that. That graph refers to exercise 3. And also posted in Canvas is this version of exercise 3 where I went ahead and did what I did with exercise 1 and 2. So we have copies of the function f drawn for each part of the problem a, b, and c on a grid so that you can more easily sketch the transformation right on that grid. So just rely on this separate posting for exercise 3. And let's go ahead and do it. All right, so let's see. In part A, we're taking the graph of f and we want to graph 2 times f of x. So it's a stretch, just like that square root stretch that we saw. And maybe the easiest point to think about is this point 3 units up, 4, 5, 6. It's going to be stretched out twice as far. So it's going to be stretched out to 6 units up. The points that are on the x-axis aren't going anywhere because you know their y-coordinate is 0, 2 times 0 is 0. So they stay put. But 2 times 3 is 6. That point 3 units up gets stretched out 6 units up. So think of the x-intercepts are pinned down, but the graph in between gets stretched out, and it's definitely like that point 6 units up, that's stretching us out. For this other little portion below, when you stretch in a negative direction, of course you stay negative, right? So we're going to stretch this -1 point out to -2. But again, these at the ends, these x-axis points are just going to stay put. So we get stretched like that. There is our stretching. So we're stretch by a factor of 2. And there we can see the effect of that stretching. In B, it's kind of a similar thing. We're multiplying by a constant here, but we're going to compress by 1/2, or 0.5. The 0 points, the points on the x-axis will stay put, but the point that's 3 units away will end up being half as far away. That's like 1.5 units away, right? So that first lump gets shrunk or compressed. The negative portion of the graph will also get compressed by a factor of 1/2. It won't stretch out further than 1/2. So there we got it. There's our red compressed graph. I teach trigonometry also, and this is a useful little idea in a trigonometry class. Now let's go on to the third graph, C. And I didn't, again, in my box, I didn't mention a negative constant. This negative constant we're just going to think of as a combination of 2 operations. Think of it as multiplying by 3 and then reflecting by adding the minus sign. So we're going to stretch. I'm missing a letter there. Stretch by a factor of 3, then reflect through, let's see, when we have a minus sign, on the outside we reflect through the x-axis. Okay, so maybe I'll do my stretching first. 3 times 3 is 9, so this first lump is going to get stretched all the way up to there and down to there. -1 stretched by a factor of 3 gets stretched out to -3. So my blue graph reflects the stretching without the reflection. And then when we reflect, instead of going up here to 9, we come down to -9. And so the zeros are all going to stay put in the reflection also. So notice those x-intercept points for this whole transformation don't move. But when I now reflect, I go all the way down 9 units below. So I have this point 1, -9 on the graph. And this point -1, -3 is going to become -1, +3 will be on the graph. So this little lump gets stretched this way in the final result. And so that red graph shows the effect of multiplying by -3. I mean, it's a stretch with a reflection.